Welcome everyone. In this video, we are going to learn graph coloring. First of all, let us understand that what is dual graph of a map. Each map in the plane can be represented by a graph. To set up this correspondence, each region of the map is represented by a vertex. Edges connect two vertices if the regions represented by these vertices have a common border. Two regions that touch at only one point are not considered adjacent. The resulting graph is called the dual graph of the map. Possibly you might not have understood the idea here. So to make the idea clear, I have taken this example. So this is a map given, right? And suppose I want to color this map. So before I color this map, I want to change this map into its dual graph, right? So how the dual graph is obtained? So they are suggesting that there are different regions in the map like A, B, C, D, E, F and G. So for each region, I am going to take one vertex. So we have the region A, so I am going to take a vertex A here. We have the region B, so I am going to take the vertex B here. We have the region C, so I am going to take the vertex C here. We have the region D, so I am going to take the vertex D here. Let me name it, otherwise we will forget. So this is the vertex A, this is the vertex B, this is the vertex C, this is the vertex D. And we have the region F, so let us take F over here, right? And we have E, so let us take E over here. And we also have G, so let us take G over here. One thing you might have noted that when I am taking the vertices, we are placing it in such a way that it somehow corresponds to the placement of the region in the original graph. Now what they are expecting us to do, that if you look at the region A, it is sharing its boundary with the region B, because this is the boundary it is sharing. You can see that it is sharing its boundary. So since A and B are sharing its boundary, so I need to join an edge between A and B. You can clearly see that A and C are also sharing its boundary, so I need to join the edge between A and C. A is sharing its boundary with D as well. This is the boundary with A and D. So I am going to join A to D. And any other region with it, yeah, it is sharing it with E also. So I need to join the edge between A and E. So let us check whether we are done with A or not. So A is sharing its boundary with B, with C, with D and with E. So we are done with A. Now let us move to B. So B is sharing its boundary with A, so we already have an edge between A and B. We need to join the edge between B and C, so I joined B and C because they are also having a common boundary. And B and D also have a common boundary, so I need to join B with D. Okay. Now I guess I am done with B because B is sharing its boundary with D, C and A. Now let us move to C. So C is sharing its boundary with A and B, so the two edges between A and C and B and C are already drawn. We need to draw the edge between C and D because C and D are also sharing its boundary. Okay. Now I think we are done with C. Let us move to D. So D is sharing its boundary with A, already joined. D is sharing its boundary with F, so let us join D with F. D is sharing its boundary with E, so let us join D and E. D is sharing its boundary with G, so let us join D and G, right? So in this graph, I think D is sharing its boundary with all the other regions, like with A, with B, with C, with D, with E and with F, right? So here also you see the degree of D is 1, 2, 3, 4, 5, 6. So we are done with D also. Now let us go to E. So E has its boundary common with A, so already an edge, with D already an edge. with F, so I need to join an edge between E and F. And E is sharing its boundary with G also, so I need to join an edge between E and G. So I think we are done with E also. E should have degree 1 because A, then D 2, then F 3 and G 4. So its degree should be 4, 1, 2, 3, 4. I hope you are getting. Now finally let us come to F. So F is sharing its boundary with D, with E already joined, with G also. So let me join E to F to G, and we are done with F. And if I talk about G, G has its boundary common with D, already has an edge between D and G. D and F already has an edge, and D and E also we have an edge. So this graph that we have got is the dual graph. If I call this map 1, so and I call this graph G. So what is G? G is the dual graph of map 1. Now this kind of question will be asked, that how to write the dual graph. We are going to look at how to assign colors to that, but before that let us take one more example. So if I ask you that find the dual graph corresponding to this map, so what you will do? Here you have the region A, so I am writing the vertex A. You have the region B, so I am writing B. You have the region C, so I am writing C. We have the region D, so I am writing D here. And we have the region E, so I am writing E here. So there are 5 regions. And A is sharing its boundary with B, C and D. So I am joining A to B, A to C and A to D. Okay. Now B is sharing its boundary with A, C and E. So A, C and E. So done with B also. C will have its boundary common with all the 4, A, B, D and E. So A, B, let me join to D and let me join to E. If I talk about D, D has its boundary with E, A and C. So C and A we already have an edge, we need to join with E. So what we have got? We have got a dual graph of this. So this is the dual graph. So this is the first part of this video, that how to represent a map through the dual graph. Now moving forward, let us understand that what do I mean by coloring of a graph. And let me change the color, because in here I am using the red. So what do you mean by coloring of a graph? A coloring of a simple graph is the assignment of color to each vertex of the graph so that no two adjacent vertices are assigned the same color. So we color the vertices in such a way that no two vertices are assigned the same color, right? We are going to look at some examples also, but before that let us look at this definition, and it is very important definition. The chromatic number of a graph is the list, and here I am highlighting this list number of colors needed for coloring of this graph. The chromatic number of the graph G is denoted by chi G, where this is a Greek letter chi, right? So what is the chromatic number? Chromatic number is the least number of color needed for coloring of a graph. And what is coloring of a graph? By coloring of a graph we mean that its vertices should be assigned colors in such a way that no two adjacent vertices get the same color. And there is a very popular and famous theorem that is known as the 4-color theorem, that the chromatic number of a planar graph is no greater than 4. Means that if we have a planar graph, we can color it with at most 4 color, right? So it can the planar graph can't have color chromatic number more than 4. Yes, I hope that 4-color theorem is clear to you. Now let us take some example. So suppose we have to color this graph, means we have to assign colors to the different vertices. So to color this graph, let us check that what is its chromatic number and how the color should be assigned. So suppose I assign red color to this vertex. I am writing R for red. Now since B is adjacent to A, So I can't assign red color to B, I am assigning blue color to the vertex B. And this vertex C, you note that adjacent to B as well as A. So neither the blue color can be assigned nor the red color can be assigned. So suppose I assign the green color, right? Now I move to the vertex D, and now we can clearly see that D and A are not adjacent, so I can assign red color to this. Here we need to keep the colors as less as possible. And one another thing that you have noted, that if we have a circuit of length 3, then all these vertices must be assigned the different color. Now we have assigned red color to this. Now if I look at E, we can't assign blue or red because E is adjacent to blue color vertex also and red color vertex also. But clearly E is not adjacent to C, so we can assign a green color to this. And again here you note that this vertex can be assigned either blue color or red color, because we can see that G is neither adjacent to D or B. So let us assign it red color. And if I look at this here, we can't assign red or green, so we can assign blue color to it. So now how many colors are needed to color this graph? We required 3 colors. So what is the chromatic number? Chi G for this graph. So chi G, this graph is G, is equal to 3, because we require minimum 3 number of colors to color this graph. Okay. Now let us take another example, and in this example we are going to find the chromatic number of the graph H. So starting with vertex A, suppose I assign red color to this, we have to assign suppose blue color to this and green color to this. I did not think much because here it is a triangle, so certainly it should have different color assigned to its vertices. Triangle means, by triangle here means we mean a circuit of length 3. Now if I talk about D, D is not adjacent to A, so I can assign a red color. And here we can assign a blue color because this is not adjacent to B, so I can assign a blue color. And here I can assign a green color. Okay. Now if I talk about the vertex G, G we can not assign green and blue because they are adjacent to E and F. And we can't even assign red color because you see that A and G are also adjacent because there is an edge between A and G. So we must have to assign a color other than green, blue or red. So suppose we assign yellow color to this. So how many colors are needed to color this graph? We required 4 colors, so the chromatic number of this graph is equal to 4. I hope this point is clear to you. Okay, so how to find the chromatic number of a graph? Now what we are going to discuss next, that we are going to discuss the chromatic number of some special graph. So we are going to look at what is the chromatic number of a complete graph, of a cycle, of a bipartite graph, of a complete bipartite graph, of wheels graph and cube. Okay, so let's start. So before we talk about chromatic number of standard graphs, let us quickly find the chromatic number of the dual graph of this map, because sometimes I have noticed that in exams usually they ask this kind of question, that they will give you a map and then they will ask you to write its dual graph and then find its chromatic number. So let us assign color to this. So suppose I assign red color to this vertex, and you can see that this forms a circuit of length 3, so we have to assign different color. So I am assigning blue color and I am assigning green color. Now if I look at this vertex here, it can't be assigned blue, it can't be assigned red, and it can't be assigned green because this is adjacent to all the 3. So suppose I assign yellow color to this. Now if I come to the vertex E, E can't be assigned yellow, E can't be assigned red, E can be assigned green color or blue color. So suppose I assign it green color, right? I hope you understand that E is not adjacent to C and E is not adjacent to B also, so I assigned green color. And if I look at this here, this G vertex, I can't assign it green or yellow, so let us assign a red color to this, because these two are A and G are not adjacent, and here we can assign it blue color because this B vertex and F vertex are not adjacent. So what is the chromatic number of this graph? The chromatic number of this graph is equal to 4. I hope you are clear. In case if you are not, please try it yourself and then let me know that whether it is correct or not. Now let us find the chromatic number of some special types of graph, and this is very important because they ask a lot of questions in exams related to this. So first we are talking about the complete graph Kn. So if you look at Kn graph, if I ask you what is K2 graph, or for that matter K1 graph, so this is your K1 graph, just one vertex. So if you have to give a color, you can give just one color, red. If you talk about K2 graph, so K2 graph is what? K2 graph has two vertices. So if you give red color to this, you have to give blue color to this. Suppose I talk about K3 graph, so there are three vertices here, and this forms a circuit of length 3, so we have to assign different color, red, blue and green. And if I talk about K4, so K4 graph looks like this, 4 vertices, and every vertex is joined to all the remaining. So you know the property of a complete graph. What is the property? That if I assign blue color to this, since this vertex is joined to all the remaining 3, so other 3 can't be assigned blue color. So suppose I give red color to this. Now this vertex is adjacent to all other 3, so I can't assign blue or red to this, so I must have to assign green to this. And now this vertex is also adjacent to all the 3, so I can't assign blue, red or green, so I have to assign yellow color to this. So if you remember the characteristic of a complete graph, the complete graph has this characteristic that every vertex is adjacent to all the remaining vertices. Yes or no? So once we assign a color to any vertex, all the remaining n-1 vertices can't be assigned that color. And same is true with all other vertices also. So second vertex, if you assign suppose blue color, then remaining n-1 vertices can't be assigned blue color. So every vertex must be assigned a different color. So if there are n vertices, how many colors are needed? We need n colors, right? So the chromatic number of a complete graph with n vertices is equal to n. So you need to remember this. And as you can clearly see that K1, K2, K3 and K4, so K4 can be assigned 4 color, and from 4 color theorem also we know that if we have a planar graph, maximum colors that we need is 4, and here we can color the vertices with 4 color. But if you talk about K5, we know from our previous videos or study that K5 is non-planar. So it is non-planar, so we can't color this graph with 4 colors. We require more number of colors. So complete graph has the chromatic number n. If I talk about cycles, so cycle has a very important characteristic. Suppose I take C3, because for cycle minimum number of vertices needed are 3. So in that case, what is the chromatic number? If I give red color to this, I have to give green color to this and blue color to this. So chromatic number of C3 is equal to 3. If I take C4, what is the chromatic number of C4? So you can clearly see that if I give red color to this, I can give green, I can give red, I can give green. So chromatic number of C4 is equal to 2. If I talk about C5, 1, 2, 3, 4 and 5. So these are 5 vertices here. And suppose I can give red color, I can give green color, I can give red color, I can give green color. But this vertex can't be assigned red or green, so I must have to assign blue color. So the chromatic number of C5 is equal to 3. So did you notice a pattern? Before I tell you the pattern, let me quickly go to the next page and draw the C6 graph so that the pattern is very clear to you. So this is your C6 graph, 1, 2, 3, 4, 5 and 6 vertices. And if I assign red color, I can assign blue color, I can assign red color, I can assign blue color, red color and blue color. So chromatic number of C6 is equal to 2. So the pattern that is emerging out, that if I ask you what is the chromatic number of Cn, so there are two possibilities. It is 2 or 3. 2 when n is even and 3 when n is odd. Right. Now this is a very important remark, because we can also prove that any graph is bipartite or not using the idea of this graph coloring, and that I will explain. But before that, let me quickly go to the other type of graph. So for complete graph, the chromatic number is n if it is kn. For cycle graph, the chromatic number is either 2 or 3 depending upon if n is even or n is odd. Now let us talk about the bipartite graph. So suppose I take some example. Suppose I take complete bipartite example, K33 example, right? So here we can join the vertices like this, and it is very clear as per the property of complete bipartite graph that the vertices are joined in such a way that the edges connect. I hope it is K33. No, 3 3. I need to join this also. Now every vertex has degree 3. I guess, yeah, it is K33. Now for coloring a complete bipartite graph or a bipartite graph does not require much effort, because we can't have these three vertices. These three vertices are non-adjacent vertices. Those vertices which fall in the first set of vertices, if you allow me to call this V1 and V2, so this can be assigned the same color, red, 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 because none of them are adjacent to each other. And every vertex in this side can be assigned a different color. Let us call it green, 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 because none of them are adjacent in V2. So if you take any two vertex in V2, they are non-adjacent vertex, and there is an edge between the vertices of V1 and vertices of V2. So if this is red color, this can be assigned green color. So clearly the chromatic number of a complete bipartite graph, Kmn, is equal to 2. And for a bipartite graph also it will be equal to 2, because I hope you have understood the difference between bipartite and complete bipartite. In bipartite, what happens that we may have such situation that where we can join the edges like this, but it is not complete bipartite, because for this to be a complete bipartite, every vertex in this side should be joined to all other vertices. But here we can clearly see that this vertex in this side is not joined to this. Even though if I join this, this is not complete bipartite, because here the degree of this should be 2, 2, but this degree is 1 because it is just joined to one of the vertex. But for coloring purpose, if I give red color to all the vertices in this side, we can assign blue color to all the vertices in this side. So chromatic number of a complete bipartite graph or a bipartite graph is also equal to 2. One thing that I want you to understand, that given any graph, we can decide whether it is bipartite or not. So for example, I have taken C6 example here, and you can clearly see that chromatic number of C6 is equal to 2. And suppose someone asks me that whether it is a bipartite graph, so I can clearly say that it is a bipartite graph. How? Let me quickly name the vertices. Suppose I call it vertex A, vertex B, vertex C, vertex D, E, and F. So I'm going to keep all those vertices which has been assigned the same color, like A, C, and E in one side. So I write A, C, and E in one side, those which has been given the same color, and those which have been given the different color, blue, like B and D and F in the other side. Now A is joined to F and B, so we can join A to B and F, right? Here this C vertex is joined to D and B, so C is joined to D and B. And if you look at E, it is joined to B, it is joined to D and F, so E is joined to D and F. Now you can clearly see that this is a bipartite graph, because, and this is a bipartite representation of C6. So remember this, a graph is bipartite. A graph, let me write it, a graph is bipartite if its chromatic number is equal to 2, right? So here you can see that each of this bipartite graph will have chromatic number 2. If it is not bipartite, then it will have chromatic number other than 2. Okay. Now we talked about special graphs, complete graph, cycles, bipartite, complete bipartite. Now let us talk about the wheel graph. Okay. So if I talk about wheel, first of all, I want you to be clear that the wheel graph are defined in different ways. So if you read it on some other source, and possibly you may find some conflict, right? Because here in our notation, when I have discussed it earlier, I was calling this graph W3 graph. Some of the authors call it W4 also, but we will be following the same convention that we have decided to follow earlier. So if I ask you that how many colors are needed to color this graph, so there are 4 vertices. So suppose I assign red color to this, I assign blue color to this, I assign green color to this. So red, blue, green. So and for this vertex it is joined to all the 3, so I have to assign yellow color to this, right? So the chromatic number of W3 graph is equal to 4. Now if I take W4 example, suppose let me take W4, and which other people call W5, right? So sometimes a student may find, those who are watching this video especially and not the previous videos, that here I am discussing it wrong. No, I am not discussing it wrong. I am following the convention as per the Rogen book, and Rogen is a very standard book. So if I talk about W4, suppose I give red color to this, I can give green color to this, I can give blue color to this, I can give blue color to this, and I can give red color to this. So chromatic number of W4 is equal to just 3. Yes or no? Let us take one more example. If I draw the W5 graph, right? So how the W5 graph is drawn, there are 5 vertices. First we draw C5 graph, and then we have a vertex in between, and we join it to all the remaining vertices. So this is how the W5 graph will look like. And if I assign colors, suppose I give red, green, blue. Now this can be not given, we can give blue color to this. Red and green can't be given. And if I take this vertex, blue and green can't be given. So suppose I give it blue and green can't be given, and red I can give certainly. And if I talk about this, blue, green and red can't be assigned, so I must have to assign yellow color to this. So chromatic number of W5 is equal to 3. Yes or no, sorry, 4, because there are 4 colors needed. Okay, so did you notice the pattern? If it is W3, W5, we need 4 colors. If it is W4, I will take W6 example, and then I will conclude. Okay, so this is our W6 graph. Now let us assign the colors to this. So a red color, green color and blue color, right? Now this is a circuit of length 3, so I already assigned 3 different colors. Now this can be assigned red color, this can be assigned green color, red, green, again this can be assigned red color. We can assign green color to this. So only 3 colors are needed. So for K, chromatic number of W6 is equal to 3. So now we can conclude that if I have to find the chromatic number of Wn, a pattern has emerged, and it is equal to 4 if n is odd, and it is 3 if n is even. And I again repeat that when I am talking about Wn, I am talking about this n, not the number of vertices, because in W3 we are considering 4 vertices, right? So if I am talking about W3, I am talking about the wheel graph with 4 vertices, and here there is a conflict in the notation as per the different authors. So some authors call it this W3 graph as W4, but we are going to follow this notation. Okay, fine. Now let us come to this example of a cube graph. So we have seen earlier, and in case if you are finding it difficult that what is cube, what is wheel, then you should watch the previous videos. So if I ask you how many colors are needed to color Q1, so I can assign two colors, red and blue. This is Q2 graph, so I can assign red, blue, red, blue, two colors, right? So chromatic number of Q1 graph is equal to 2. Chromatic number of Q2 graph is also equal to 2. And this is Q3 graph, and I hope you are aware that there is a process to assign or label the vertices, but I am not going into that detail. I have just drawn the structure. Now if I look at the 8 vertices here, there are 8 vertices in this. So if I assign red color to this, I can assign green color to this, I can assign red color to this, I can assign green color to this, I can assign a green color to this, I can assign a red color to this, I can assign green color to this, I can assign red color to this. And you see that none of the two adjacent vertices have got the same color. So red, green, if I talk about, for example, this vertex, it is having 3 vertices adjacent. So red, this is red, and this is red, right? So any vertex if I take, if it is a red vertex, all its adjacent vertices are green. So if you take this, all its adjacent vertices are green. If I talk this green vertex, all its adjacent vertices like this vertex, and this vertex are red. If I talk about this vertex, which is green, so it has 3 adjacent vertices, that's this one, and this one. So these 3 are red. So we clearly see that chromatic number of Q3 graph is also 2. So one thing that is clear, that if you draw other cube 4, and I would suggest you, this was one of the problem that I posed before you, that how to draw Q4 graph or Q5 graph. So that is itself a problem. So in case if you are interested, you should certainly try. But the pattern that has emerged, that chromatic number of a cube graph is equal to 2, right? So we have discussed about different kind of graph. Now in the end, I want you to remember this table, which I have especially separately created for you, so that you can have all the details on just one page. So what is the type of graph? If I talk about complete graph, its chromatic number is n. So K3 will have 3 chromatic number, K20 will have 20 chromatic number. So the chromatic number will depend on the value of n. Complete bipartite graph, chromatic number 2. And to check whether a graph is bipartite or not, we can use this idea also, that if chromatic number is 2, then the graph will be bipartite. Chromatic number of cycles, 2 when n is even, and 3 when n is odd. So this is clear that if I am talking about a cycle with an even number of vertices, that will be a bipartite graph also. And we just saw that if I talk about wheel graph, it is 3 when n is even and 4 if n is odd, right? So if I talk about W3, it will be 4. If I talk about W4, it will be 3, and so on. And if I talk about Qn graph, the chromatic number is 2. So this is a very important slide, especially for a lot of multiple choice question may be framed from this, right? So this was all about graph coloring.